This is note 6.4 to 6.5b. It is still over rectangles, rhombi, and squares, but we're going to add a little bit more dimension to this. So the first thing you need to do is remember that chart that we talked about in class. This is the part that has to do with parallel, rectangle, rhombus, and square. So real quick, stop the video and see if you can fill in all the information for this grid. So something you need to notice is the opposite sides are all congruent and parallel for all of these types. Consecutive sides are either perpendicular for a rectangle, congruent for a rhombus, or both of those for a square. So a square is everything that the rectangle and rhombus is, but a rhombus is not always a rectangle, and a rectangle is not always a square, but it could be. Okay, so we're going to determine whether something is a rectangle. You have to first decide if it's a parallelogram, and then you have to decide if one right angle is, if consecutive sides are perpendicular or if the diagonals are congruent. If you're looking at whether a figure is a rhombus, you need to determine it's a parallelogram, and then you have to decide if there are two consecutive congruent sides, or if diagonals are perpendicular, or if one diagonal bisects a pair of opposite angles. So that would be a test for that. To determine if a figure is a square, it has to have all of the properties of a rectangle and a rhombus. So all of these tests would apply. So here's TRKY is a rhombus, and the measure of angle RSK, that's this angle, is 3x minus 6. The measure of angle RTS, that would be this angle, is x plus 2. And then from there you're supposed to find the measure of angle TRK, or TRY. So this is the one that we have to find. So first let's go over the properties. I see that 3x minus 6 is pointing to the diagonal angle. And I know that the diagonals are 90 degrees or perpendicular. So if they're perpendicular, that means that 90 equals 3x minus 6. So I know that 96 equals 3x. So x equals 32. Once I know that's 32, then I know the measure of angle RTS equals 32 plus 2, which equals 34. So I also know this is 90 right here as well. So this is a right triangle. If I take that all out of there, this is 90, this is 34. So this one has to be 56 because the acute angles in a right angle add up to be 90. So I know the measure of angle TRY equals 56 degrees. So you really have to know these properties and say, okay, they gave me this information, what property applies to this? Next one, you try this one and see if you can get this figured out. So go and label it, look at what you've got, pause the video, and then come back with your answer. So because this is a rectangle, I'm going to go ahead and label everything I know about this. I know opposite sides are congruent. I know that this angle is congruent to this angle right there. I also know that diagonals bisect, but I also know that the diagonals are exactly the same. So by side, 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 or by side, angle, side, either one. These are, the left triangle is congruent to the right. And since the sides are the same, with the 3 tick marks, this is an isosceles triangle, which means that the two bases of that triangle have to be the same. So I know that 7y minus 6 equals 5y. So I know that 2y equals 6. I know that y equals 3. So if I want to find the measure of angle BDA, I happen to know that this is also, if I look at just triangle BDA, I know that this is 90 degrees. I know that 5y is right here, so 5 times y is 15. And then from there I can figure out BDA, because this is going to be 90 minus 15, because those are the acute, that's one of the acute angles in a right triangle. So I know the measure of angle BDA has to equal 75 degrees. So there would be the answer for that one. Let me clean that up. Okay, 2 more for you to try. Pause your video, try these, and then we'll come back and check them. First one, if I go and I label everything I know about this rectangle, the diagonals are the same, but then they're split, so that means that all 4 of those split segments that make up the bisected diagonal segments are congruent. I know that this is an isosceles triangle, so I know that this is congruent to that, so that also is 8x plus 4. And 8x plus 4 and 3x minus 2 are added together to make a 90-degree angle. So I put those 2 expressions together to equal 90, and x equals 8. This one looks like a really weird one. I mean, it's hard because what's what? It's not a rectangle, no isosceles triangles, but think about the properties of a rhombus. The diagonals bisect the angle at the vertex, so this also is 39.5. So if I put those 2 together, the measure of angle WZY is 79. And then these 2 angles are supplementary. So 180 minus 79 equals 101. So the measure of angle ZYX equals 101 degrees. These are the figures I was talking about where you have to be pretty clear about whether, about the congruency marks. All of these look like they're rectangles, right? But based on the congruency marks, we can only follow what's actually marked on the drawing or mentioned in words. So we're going to go look at this slide again and see what we need to do. Okay, if it's a rectangle, it must be a parallelogram, then there's one right angle, and then congruent diagonals. So, and then a rhombus, 2 consecutive congruent sides, perpendicular diagonals, or one diagonal bisects a pair of opposite angles. So let's look at what's going on with this one. On this one, I see the diagonals are bisected. And I see a 90-degree angle. Because the diagonals are bisected, I know right away that this is a parallelogram. But then, this little piece of information takes us one step further. So this one is a parallelogram, but it's also a rectangle. And it's a quadrilateral. The most specific one it is a rectangle. But we list all 3 because it really is all 3. Okay, this one right here definitely is a quadrilateral. I see that 90-degree angle, but it doesn't tell us what this angle is or that angle, and it doesn't tell us any measures of any sides. So all we know is there's one right angle. Looks like a rectangle, but it is not a rectangle. But the furthest you can get on this is it's a quadrilateral. Okay, this one, definitely a quadrilateral. But then we need to look and see if there's anything that says it's a parallelogram. So think about it. Opposite sides are congruent. Nope. Opposite angles congruent. Nope. We don't know anything about that. Diagonals bisect. We don't know anything about that. Adjacent angles, consecutive angles are supplementary. Nope. So I just go down the list. And finally I get to this one. It was a test for whether this is a parallelogram. And the test was that if there's one pair of opposite sides that's both parallel and congruent, then it is a parallelogram. So this is a parallelogram. But then we have to go down one more and see, is this a rectangle? If it were a rectangle, I'd see diagonals that bisect, or perhaps a 90-degree in the corner, and there's not. Square, Again, you'd have those right angles. So the only other one it might possibly be is a rhombus. And with a rhombus, what distinguishes a rhombus is the diagonals are perpendicular, not happening here. We don't know what the diagonals are, but we do have this piece of information right here. So if one consecutive, all three of these are the same measurement, and this is a parallelogram, then this definitely is a rhombus. But it's not a square because there's no right angles. Okay, you guys try this one. Pause the video, think about it, see if you can come up with this one. So for this one, I've got two lines that are congruent to each other. I don't know anything about this side and this side. Looks like they might be parallel, but I don't know. There's nothing to tell us. However, I do see that I have a transversal going through these two lines, and we've got alternate interior angles that are congruent. Since that's the case, then these two lines are parallel to each other. So this one is a quadrilateral, definitely 4 sides, and it is a parallelogram because the opposite sides, one pair of opposite sides, is both parallel and congruent. So this one is a parallelogram. That's the most specific one that it could be. The most specific on this one was rhombus, because we had one pair of opposite sides, parallel and congruent, and we had consecutive sides congruent. We didn't need that third side on that one. Okay, so for this one, I have diagonals in here that are marked. Not only are the pieces of them congruent, but the whole would be. So this is definitely a quadrilateral because it has 4 sides. This is a rectangle for sure. The reason why is because the diagonals are congruent. Okay, and then it's got this angle right here. So if the diagonals are congruent and diagonals cross at 90 degrees, when the diagonals cross at 90 degrees, then this definitely is a square. So the diagonals are 90 degrees, the right angles. Put right angles there instead. So if this is a square, it definitely is a rhombus, because a square is both a rhombus and a rectangle. Definitely a parallelogram then as well. So there we have it. This one could be everything. The most specific would be that it is a square.